Alright guys, so we just got done putting these ends on this 60 amp electronic speed control with an SBC. Now we're gonna get this one ready. And the only thing we need to get ready on it is we actually need to increase the size of the connectors. So what we're gonna do is we're gonna guesstimate the weight difference between these two. We're going to plug in the scale. We're going to get this thing fired up. And then what we're going to do is we're going to show the weight difference excuse me, between these two. And that's very important for us because it's going to help us to determine which one's better for our application. Okay, so remember, these pins and these pins do not weigh the same amount. Let's just see what type of difference we have. So that's 0.75 grams compared to 1.3 grams. So we got a little bit of difference here. This is a pin and this is a socket, okay? So there's going to be a difference in weight even there. So, but let's call it a couple grams if that. Okay, so we're 45.8 grams for this. 45.8 grams for the 40 amp. And then for the 60 amp, we're at 76.75. Let me make sure I did that right. Yep. Okay, so the difference in weight, so 31 grams. Okay. So we got a decent amount of difference. Bearing in mind it's not quite that much because this is actually going to add a couple grams if we go up to these new connectors or the bigger connectors. So that's incidentally our next step, is we're building 3 little adapters. That's going to take this pin and it's going to adapt it up to this size pin. Okay? And that's our next step, is we're going to do that right now. So in our application, we can't quite fit that pin in there. Sometimes you get lucky and they'll slide together, but this one just doesn't mesh. So a couple different ways you can do that. One way, of course, is to use some scrap wire that you've got lying around and just build a little jumper, which is probably what we're going to do today, just because it's easier than trying to do it any other way. Remember, we don't need a big long chunk of wire, we just need enough to make the transition. Don't even need any insulation on there, really. But if you try to do a short little piece of wire here, what you're going to figure out real quick, it's going to fall off. So maybe what we'll do is, for the first time, we'll just go ahead and try to solder them together and see how it works. So we're just going to lay these side by side. Probably going to have to put a little bit of copper between these just to hold them in place, otherwise it's going to want to roll away from one another. So we're going to take this wire and just take off the sheath. Okay, so we got that pulled off. And this will give us something, hopefully, to hold on to when we go to separate them. So we're just going to curl that up and then fold it over on itself. And so we're going to slide this into the socket, just like that. And then we're just going to lay this down. Okay. Give it a good squish. That ought to get us enough to stuff that in there. Okay. That's going to be good enough for a test fixture. Okay. Now that'll sit still. So solder iron. I'll make a drip. The drip will make contact with the metal. That's what I was afraid of. See how that one moved? Okay, so now we have to deal with that, which is a pain. But we'll be fine. We're just going to shift that over, find something heavy to hold onto this. Then we're going to slip this under it. And we're going to try again. Sorry guys, I panned down a little bit much there. Okay, so there's our test fixture. We can just let that cool in place. The fact that it's not square is not a big deal. Square would be better. Square is not critical. If I really cared, if I knew these were going to be permanent adapters, I would crush this side so that it did fit in. We got enough in that bag. I think it's worth trying. And just take this and squish it. Okay? Give it enough of a squish so that it fits in here. Not quite enough. You do a little bit more. It's actually pretty soft. Okay, make it a little bit smaller yet. We're almost there. Hopefully I don't get too far and break it, because I don't want to ruin this. These things aren't free. Okay, so you got it rolling around the edge now. But it's enough to get it in there. So we got a good adapter now. Okay, so now that one we can just set. And if it wants to roll away on you, grab a little chunk of wood, drill a hole. Once you drill the hole, this thing's probably still pretty hot. So I'm just going to let that slide over there. So in this case, I'm going to find whatever hole is close. And we're just going to slide it in there so that it holds it for us. There we go. There's one that will probably work well. And if we don't find one, we'll just make a new one. Okay. Clean the tip. Clean the tip. Okay. Got a little bit of a drip going, no big deal though. Okay, so I'm actually going to knock that down so that the drip will not keep dripping down the side. Okay, so we're just going to let that cool over here. And that seemed to work a little bit easier, but I'm sort of afraid I'm going to end up breaking it. So I guess we'll just do a little piece of wire on this one. Now, if you really wanted to do this as an extension cord, you would strip back your lead. You do whatever it is you're doing, and then you would cut the lead to length after you're done. with the understanding that if you do it really close, the heat's going to go back through and try to unsolder the other side. So, in this case, we're just going to do it with bare wire. Take it apart, spin it, fold this over, bite it with the tool, feed this in. That gives us somewhere for the solder to go. And then we'll just rest this down like that. And there's actually a million ways to do this, of course. This is just one way that took me 10 seconds to come up with. Probably better ways to do it. You just kind of got to get it where you need it at the beginning. Need something to hold this steady. Keeps wanting to roll away on me. Okay, there we go. Letting that set up to cool. Good enough. Alright, so now while that cools down, we'll just give them a little, yeah. This first one we did, it's still warm. That's crazy. Not really surprising, I guess I shouldn't say it's crazy. Okay, so this one's ready to adapt here. Doesn't matter which one it goes into. Just want it to go in one of them. If you ever have one of these that's fitting loose, it's because it's collapsed slightly. So what you can do is you can take a real fine tip screwdriver, or you can take an X-Acto knife, which we're going to have to go with an X-Acto knife on this one. Get the blade of the X-Acto knife, walk it in there, see how it's opening up? So that takes those leaves and spreads them. And then you'll find that you have decent pressure again. This one's still toasty too, but it's not hot. Okay, same thing's true on this one. Just opening up the leaves. You can use your fingernail if you got fingernails enough. Okay, so that's good. And then the last one's still probably pretty hot. You can smell test it to see how hot it is. The other thing is you can set it on a heat sink, like a cast iron piece or something like that, or grab it with a tool that's got a lot of metal. Okay, it's warm enough to where you can handle it. Cool. So now obviously if you were testing this and those things touch, that would be a bad day for the ESC, potentially for you. So you'll just have to decide how you want to handle it. I'm probably just going to throw a bit of tape around it. Actually, you know what I'm going to use? I'm going to use some crappy heat shrink. Crappy heat shrink, not good heat shrink. This is thinner stuff. But it'll work fine for this. And crappier heat shrink meaning it's not as thick. and it's cheaper. Not really going for perfection here, we're just going for a temporary test. But I want you guys to see these steps, because these are the steps that everybody assumes when you're making YouTube videos. It seems like everybody assumes everybody knows how to do this stuff. And I suppose if you're doing this type of project, you probably do know how to do a lot of it. But maybe you don't. Oh, shoot. That was an accident. There we go. Okay. So we got that heat shrink down. So now we're in the process of finishing our actual test. So we want to compare this to this. And the other thing we want to test is to see if I need to center the hole on our adapter here. So the first thing we're going to do is we're going to open up our 11RX 7-channel with stabilization receiver. Be careful not to cut your antennas if you buy this. Here's the part number. Basically what this is the one without plus. They have stabilization, they have stabilization plus. Stabilization plus attempts to auto level the wings. We're not going to be doing that. The stabilization plus is, in my opinion, doesn't really add that much value, because then it has to sense a level condition as opposed to just a stable condition, and I found that it's just not super effective. I mean, it works, sort of, but I would say it's 90% working. 90% holding level is not enough for me. So we'll put the bind plug on here. And what we're going to do is we'll probably go ahead and start with the smaller one. And we'll just set that aside for now. We'll go ahead and plug in. This is the regular lead. This is to control the reverse if we decide to reverse the motor. Condition the throttle output so you can reverse the motor. The BEC is a little bit smaller on this one. So we'll get that plugged in, and when we get battery plugged in, then we can go ahead and test this. But one of the things we're going to have to do here shortly is we're going to have this mounted so that we can spin it up. So what I have to do is I have to figure out, okay, so on this hole there's some tapers, and what we're going to do is we'll just kind of put this together for now. Obviously a static test is always a little bit different. Maybe not quite as good as a dynamic test. These are Phillips screws. That's unexpected. We should be able to unplug the soldering iron too. Phillips is a little strange for this. Oops, I got that. Evidently this is different dimensionally from one direction to the other. So you have to put this in the correct orientation or it won't work. The holes won't line up. It's kind of weird too. Okay, so once we get these tight, or finger tight, we'll go ahead and torque them down real quick. Once it's torqued down, we'll go ahead and throw some screws into the motor mount, and then we'll have this thing fixed. 2 pieces of wood that we can clamp to the bench. Once it's clamped to the bench, then we'll be allowed to safely test what we need to test. Just want to make sure we don't compromise anything in our testing. For quality, we don't want to overheat anything. We don't want to, overload it, melt any coils, damage anything. Okay, so we got that all torqued down. So now we need to just come up with some sort of a piece that we can screw this into. Got some lumber under here. That looks like it's pretty satisfactory. Just about 100% sure that can't blow away. Now normally I would want the wires on the bottom, but for our test we're really only just trying to make sure the thing don't fly away. So I think we'll be safe, but how long is our prop going to end up being compared to our wood block? That wood block is quite heavy. Let's see. I could give you an estimation, or I could give you the actual measurement. So this is Aeronaut brand. These are 12.5 prop blades. Yeah, and they're labeled on there as well. That's good. And we have a flat-bladed screwdriver on here, alternating. One side's pointed in from one side. The opposite side is pointed in from the opposite side to help keep it all balanced. That's pretty awesome. So we'll just go ahead and get this assembled here loosely. Well, actually, we want to put it together like permanent because we don't want it to come out spinning. Shoot the blades across the room. And this type of thing is not hard at all, and I suspect that 95% of you guys out there have probably already done this if you're watching this video. But if you haven't, that's how you do it. Probably apply a little Loctite later, or a little drip of CA on either side just to hold it, which can throw your balance, so just be aware. I'm going to lay this out of the way so it doesn't get blown away later. Nothing worse than searching for packages for product information later on. Okay, so if this were mounted, you can see that we don't quite have enough height there. So we're going to need to get either a bigger piece of wood, or we're going to have to put it this way. So why don't we try putting it that way and see if that gives us enough room. And of course we'll clean the crap off of the counter before we run the test. But you can see that that'll give us clearance, so we're not going to hit anything. And so our next step is to get some screws that will be acceptable to hold that in there. I think these screws actually are suitable to get that held on there. Might as well just use what come with it for now. Okay, so we'll get in there. Remember guys, it's just a bench test, so nothing real particularly magical about this. It is a temporary thing for testing, and we're going to take it all apart. We just need to be safe while we're doing it. And we also want to make sure that we emulate reality as close as possible. And one problem I'm noticing is when I go to mount this, the motor wants to hit. Well, that's not cool. And I'm pretty far down there. You don't want to strip these screws, so I'm going to go up to a different screwdriver. See if we get a little better bite. Nope, we're not. So we're going to have to do a pilot hole. Now, excuse me. The other thing we could do is we could go into a different material. I don't think I want to screw around with all that. Okay. Pilot hole number 1. Okay, got the pilot hole number 1 started. Yeah, we'll be good there. We may not be able to get a second hole. That's why I decided to go with only screwing the one single pilot hole. Okay, so that's spinning free now. As you can see, I'm up high enough that I'm not going to hit that wood when I get my screw in there. So That means I'm going to be tightening this tight. And then I'll have to brace it another way somehow. Or just, I don't think I want to risk damaging this all. Okay, so that's pretty tight now. So that's pretty secure for the moment, provided it doesn't have a bunch of oscillation in it. I think we'll be okay. So now I just need to pause it and clean up a little, and I'll come right back. Okay, so one other thought I had was, since I can't get a second mount point on the frame of the bracket, I'm going to pre-drill another hole and then throw the other screw in to help sandwich the frame, and that's going to help give us a little extra bite. And like I said, this is a test, it's not permanent, so I just wanted to show you that real quick as I was still cleaning up. Alright guys, so we're getting ready to do our test. 3S2200 60C Turnigy heavy duty XT60 end on it. 12.3, 4.13, 4.11, 4.15. Okay, we'll leave that on the whole time. We're going to go into the system setup on DX18 by Spectrum. Model select, all the way to bottom. Add a new model. Create. Aircraft type. Technically we can do normal and normal, but we can also do model type. We could do a sailplane. Sailplane type. 2 ailerons. Switch A, B, C, or you can do the throttle stick. Next. I got a bunch of images. So that would be satisfactory. Then that gives you more flight modes and stuff like that. But in my experience, it just, unless you're using a wing like that, it's just unnecessary. So I'm going to go back to model type. I'm going to change it to a regular airplane. Yes. Aircraft type. We go to next. Change the picture. Back a couple from the end. Booyah, there you go. I'm going to change it normal to flaperon. We're going to go back out. Stabilizer is going to be tied to this. Stabilizer on off is going to be tied to this. We're going to go back to system setup. Yes. Channel assign. Gear is still gear, but then we're going to make an assignment for gear to switch D. Auxiliary 2. Excuse me. D. Auxiliary 3 is the right knob. That's correct already. So that's our sensitivity, our master gain on 11RX7 channel with stabilization. Obviously we haven't renamed this. System setup, yes. Model name. And this is going to actually be, and I'll pause it and you guys can see when I'm done. Okay, so ASH26 2.6 meter CMPro.